Okay, I want to welcome everybody to today's presentation with Richard Vandersteen. Everyone, I think, knows Mr. Vandersteen. He started building speakers, I believe, back in 1972. And Vandersteen Audio was created, I believe, in 1977. His speaker designs have focused, at least initially, on baffle-free speaker design in the effort to reduce secondary radiation from drivers, time and phase correct speakers, and he utilizes primarily, or at least in some of his designs, first order crossovers, which he feels is superior to other crossover designs. In today's presentation, we're basically going to be question and answers. If you would put your questions into the chat area, I will then read them and give Richard a chance to answer them. I also have some questions I'm going to ask of him. I'm going to start with a few of my own. And then as questions from our audience come in, I will then read those questions and let Richard then answer them. So what I initially wanted to ask Richard was what got him into the interest in speaker design back in the 70s? And have you always had a hankering for audio and music reproduction, or are you just kind of a inventor, fiddler of all kinds of things, and somehow you came upon speakers, or was this something you've had an interest in for quite a while?
Well, in a way, it's kind of all of the above, but mostly it was because my father was a tenor, and we didn't have a television. He was an immigrant. Mom and dad immigrated from the Netherlands, and there was no TV in the home, but there was always music. And built my first tube amp to improve the sound of his console, and played with speakers. Anyway, it was always an interest, and then went into the Air Force during the Vietnam era, and they put me in electronics, went to their schools for that, and it was just something I really enjoyed. But didn't go into electronics, stayed with the loudspeakers in the beginning, and came up with an idea that was discovered by friends who had a hi-fi store in Visalia, and they felt I knew nothing of the industry at that point. They felt that this was worth taking to the Chicago show in '77, and we drove out there in a van and did our display, and came out of there with with 7 of the original dealers. And I don't know how many speakers Son ordered, but at that time I was making a pair or two a month in the garage while working full time. So anyway, it was a quick start.
Awesome. I know a lot of your earlier designs, as I mentioned earlier, you focused on first order crossovers. And is that still pretty much something you've stuck with for your crossovers in your speakers, or just certain speakers within your current, what you're currently making?
Well, actually, the first speakers I made were more like disco speakers. They had multiple woofers, multiple mid-ranges, multiple tweeters, very, very efficient, played very loud, all basically in a well-constructed box. And that was actually what I started with. And once I decided that, or my wife and I decided that maybe we could make a living at this, the marketing people had a discussion one Thursday about East Coast sound, West Coast sound. I didn't know what they were talking about. And I was so discouraged. I drove home that night. Visalia is about 20-mile drive. I drove home that night and told my wife, now here we've decided to make this a permanent business, and the marketing people can't decide what the speaker should sound like. And during that week while at work, I, I says, you know what? So the next Thursday when we had our weekly meeting, I says, guys, why don't we try to make a loudspeaker that replicates what the amplifier is sending to it? And Nevin at that time had a Revox machine and some really good ribbon microphones. And we started recording music, instruments, scraping shovels on concrete, shaking car keys, pounding on the inside of cardboard boxes, and just getting the visitors that came to these events to basically vote on which one of the designs that I had prepared that week sounded the most like what we had just recorded. And that whole process over a couple of years, the first thing we had was, the multiple mid-ranges went away, and we had one mid-range up on top of the box instead of in the box. And then the tweeter ended up outside the box. And then so now we had a tweeter and a mid-range on a stick. And then the alignment became an issue, and they were steep order filters. And then they became first order filters and the whole alignment thing. Anyway, the end result of all of that listening and recording and evaluating over a year or two's time resulted in the original Model 2, which was a very different speaker than what we started with. Today, even the Model 7 Extremes, everything we make is still based on that original set of all of that trial and error and listening and recording, to the point where I made my own recording and have my own master tapes, because you never really know what music sounded like when it was made. Not being there, I needed to know to go further in speaker develop. All of that reason, to make a long story short, all of that ended up in the Model 2, and is still the basis of what we do today.
Awesome. So when you're designing a speaker, you talked about speaker amplification matching, getting the amplifier to work well with the speaker, so it's giving you the best sound, most realistic reproduction. Since you've started at Vandersteen Audio, when you work on your various designs, and if you're starting from scratch, like when you were first thinking of doing the fives, or first doing the sevens, do you design the speaker with a specific type of amplification in mind, thinking that, because I know, for example, a lot of your speakers in the past you've used the tube amplification. And not all speakers obviously do that, and not all even efficient speakers may work with a particular type of tube amplification just because it's efficient. So is that something that you keep in mind as you are starting from the ground up and thinking about a speaker design, from the drivers through the crossovers, in terms of having it work well, with a particular type of amplification?
Well, I was not totally aware of why, but back, many years ago, um, being time and phase correct, which is really a complicated way of saying whatever waveform, pressure waveform that an instrument makes when it produces its sound, whether it's a guitar or an oboe or a trumpet, uh, whatever that waveform is, it is preserved very well by microphones, wires, preamps, power amps, um, and is the harmonic structure of it and everything, I feel, is a very important part of reproducing that instrument in a way that makes you say, that could have occurred right here. Unbeknownst to me at the time, the amplifiers that seemed to do that most faithfully while we were doing all of this research on the speaker were tube amps at the time, because most of the solid state amplifiers had a lot of feedback. And I didn't know this, I didn't realize this, but feedback messes with that timing. made those timing signatures less audible. So it was kind of, yeah, so it wasn't a deliberate thing. It just allowed us to hear more of, for instance, a rim shot. That involves a woofer, a mid-range, and a tweeter. Okay, typical today, you have a lot of speakers with every other driver out of phase. Now, there's a very good reason for that. But if you have something as simple as a rim shot that involves the woofer, tweeter, and mid-range, and it's one sharp leading edge, having that all aligned in all positive pressure in the room as far as the waveform's concerned, impacting your eardrum is going to be more dynamic. When I say dynamic, not necessarily loud, but it's contrast between loud and quiet. And it's in fact, very efficient speakers tend not to do that well because they have a lot of cone breakup in order to do that. And that cancels some of that real dynamic contrast, but in my opinion. But so having that all aligned just was more to my liking, more of what I was trying to accomplish. In the early days, mostly because I didn't have the faith to make the determination as to what, quote, sound would sell best and assure a livelihood for my family. I was nervous about making that choice for people. So early on decided, hey, I'm going to try to make a speaker within the limits of cost and technology that is has as little character as possible. Character being a lot of most speakers are designed with the tweeters excessively bright just to make them sound more hi-fi. Time has proven that that's an easy way to sell speakers, and at least long enough for the check to clear. But it negatively impacts the amusement and the enjoyment of music, in my opinion, because there's a lot of recordings of great music that are not well recorded, and it just want to rub salt in the wound, so to speak. But anyway, tube amps early on, yes,
Right.
not because I had a passion for tubes, but it allowed me to hear what I was wanting to do more clearly.
Okay. Fair enough. So do you think that currently, with the advent of just changes and improvements in solid state, that solid state amplification has improved significantly over the last 20, 30 years in order to be able to, with some of the, with less feedback or no feedback or designs, to be able to produce the music and the, with the kind of nuance and information you wanted to get that tubes were able to do earlier, but currently you think they've caught up?
Well, in some ways, I think solid state has surpassed that because the advent of having circuits that are linear enough to run without feedback and can reveal something about tube amps. There is hysteresis in an output transformer. The best way to describe what is hysteresis in sound would be if you remember the early flat panel TVs. If you were watching a basketball game and the player was running down the court fast, there was always this little shadow following him on the early flat panel TVs, if you'll recall. And that is kind of a visual example of what I mean by hysteresis. So you have this homogenizing of the signal because there's actually an image that lingers slightly after the music has changed. And solid state doesn't have that. Of course, there's other reasons. So I do believe that tubes still are superior for voltage gain, but transistors, especially in-channel devices, and if you can do what we've done is complementary circuits with all in channels where it's truly complementary, but doesn't need to deal with PN and PNP transistors because they are not equal and opposite. They aren't even close. So I do believe that that for current gain to drive a loudspeaker, that the good bipolar transistors, in our case we use Sankens, have eliminated that fuzziness that a lot of people enjoy about tube amps. It's not necessarily a bad thing. You got to remember, all of this is about what you like.
Of course, yeah,
Yeah.
absolutely.
I mean, there are speakers out there that have so much stored energy in their diaphragms that when you look at a waterfall plot, the signal, what a waterfall plot is, that last line that you see at the very back of the graph is usually the frequency response of the speaker. All of those lines coming forward in time are energy that was released by the speaker into the room after the signal stopped. So if you're trying to design a speaker that has as little character as possible, all of that stuff in the foreground of that waterfall plot is character. Again, some people like a little reverb on every note. It's like singing in the shower. Again, it's about what people like.
Right.
Whether you believe it should be a transducer or an instrument.
Well, fair enough. Getting back a little bit about phase and timing, I know this has been an important focus of yours on your designs going back a ways, and there's certainly a lot of speakers that are not phase time correct. Do you think in terms of getting that in a whole music system, having the speaker itself with its crossover and the way it's actually designed give you a phase and time correct musical response versus using a active crossovers in the digital realm to do correction after, that's not part of the speaker, but then doing that after processing? Can you achieve the same thing, do you think, if someone has a speaker that, or if that is not time and phase correct, do you think they can get there, or do you think it really needs to be integral to the design of the speaker itself?
Well, I think if someone's 100% digitally based, if their source is digital, they've already, in my opinion, taken the sonic hit. In that case, all of the processing and all of the manipulation, mathematical manipulation that goes on in doing anything in the digital domain can correct for timing and can correct for amplitude and can give you that kind of performance in a room. But in our industry, in our hobby, the excellence of performance is still today referenced to the information that's on an LP. It's still an analog world. The digital guys are trying real hard to get there. Most people, not all, but most audiophiles that I meet still think that properly playing analog setup is more truthful to the source. Um, Even those that have all analog tapes and then compare them on a digital system versus feel like the analog is still the most musical. And I don't believe that's because there's losses. I believe that's because there's more information and the information has less timing errors. But so it can be done in the digital domain, but that would require that you're going to digitize everything. And a lot of our users aren't into digital so much yet. They don't think it's arrived sonically. So it's simpler to do it right the first time and do it in the analog domain, for me anyway, but then I'm not a digital engineer. But the difference between a non-phase correct and a really well-designed loudspeaker and a time correct speaker ultimately is not a day and night thing. It's a very subtle thing. But it is the kind of subtleties that allow you more often to make the comment mentally to yourself, wow, that could have happened here. I have a 9-foot grand piano in the room right next to us there. And you're going, I hear on piano recordings many, many times where you just have this feeling, wow, that could have really happened right here. I think that preserving the waveform in its proper amplitude, phase, and time gives you that more frequently. Some people are so adamant about it, though, to where they think I'm saying that, well, if it's not time and phase correct, the speaker won't play. Well, that's ridiculous. It's going to play very well. And there's a lot of good sounding speakers out there that people love, that are well engineered, that are good in amplitude, good in distortion, good in a lot of ways, even use pistonic drivers, but are not time and phase correct. And it's like icing on the cake. It's not the cake.
So at Vandersteen, how does your company approach research and development? Do you have multiple teams? Does it kind of start with you and you have designs and you pass them along? I'm not asking you to give out secrets, but every company, at your level has just different approaches to research and development. And, some companies take years and years and years to bring a product from design concept to actually being, out there for sale. Some companies, they're always changing their designs, tweaking them, and it's, Mark 1, Mark 2, Mark 3, Mark 4, blah, blah, blah. But I'm just, in your mind, how does Vandersteen approach research and development?
Well, in loudspeakers, it's myself and my son, my son Nathan's coming on, helping with a lot of that. When it comes to our electronics, it's a team between myself and Dean Kleinfelter. And when it comes to the powered subwoofer sections, that's a collaboration between Greg Shug and myself. And so it's all sort of in-house with help. And mostly it takes a long time. People say, well, why don't you have a product priced in between this one and that one? But my experience over the last 50 years has been to make a meaningful change where somebody goes through the trouble to sell what they had used and buy the next model up and have that be a positive experience top to bottom, universal for the money that was spent and the trouble they went through. Really, these changes are difficult to come by, legitimate ones. You can always rearrange the chairs on the deck and just change it up and put it back out there and call it a Mark II. But in a legitimate way, with everything measuring better, sounding better in all ways, you're looking at pretty much 2 to 1 because of the cost of doing that. And so that minimizes how many models, and it takes a long time to get them right. For me, if there's a Mark II version within a year or a year and a half, means I didn't do my job. It wasn't finished.
Right. I have a question from one of our members here. How have you designed for the physical room variations and resulting speaker placement?
Well, the only consideration you have for rooms is whether you want the speaker that I believe in is if you want the speaker to work near boundaries, there are changes you make. You tend to dampen the mid bass and bass drivers more. You tend to lower their Q, although most of our models have room adjustments for the bass issues, so you can put them anywhere. I think that's if you can afford to do it, if the product's expensive enough. I think that's mandatory. So everything we make where we can afford to do it has adjustable bass because, yeah, that's a big problem in the bass.
Mm.
And but when it comes to room considerations, let's imagine you had a sound room that was a really nice room, but it had a hole at 500 hertz. And let's assume that we could get Mr. Horowitz to come out of the grave and play my piano here. And my room has this hole at 500 hertz. So am I going to ask him when he gets near 500 hertz to hit that key harder because I have a hole in my room? That's going to sound really weird. It won't correct the problem. The ear brain, we know that the ear brain focuses about 150 hertz and above anyway, focuses on the direct sound. If you try to EQ for that for room problems at the upper frequencies, 150, 200 hertz and above, you are going to change that direct sound, therefore the timbre and very important characteristics of that instrument if you're trying to make them sound as if they could have been there. So, except for doing bass adjustments, which in the low frequencies, the wavelengths are so long, you have no choice. Your ear brain hears what the room did and the music all as one. They can't be separated. That, I think, makes good sense to try to equalize that and correct for some problems. And all of our products have that where we can afford to do it. I would rather put it in all of our products, but it's economically not feasible.
Right. And that leads into another question from one of our members. And so it's the question is, why do most of your speakers use active woofers and subwoofers? And you've, emphasized in a lot of your designs having a high quality, high pass bypass filter and then using a powered subwoofer either separately, like your 3WQs in the old days, or built-in powered woofers. And that's been an integral design to majority, if not all, of your speakers. And what does that? Why did you come to that approach, and why do you think that is, a superior design over many of the others that do not go that way?
Well, it's a good question, and I've often wondered why it wasn't more mimicked, but then Brad and I know why, because it's 90% of the frustrations that people have with our product. They think it's complicated. So it ends up representing about 90% of our technical support. And probably if you were running to run an efficient business, you wouldn't be dumb enough to do what we've done. But the reason I did it is I don't think there's another answer. I think it's that important. Bass is the foundation of music. Without bass, in my opinion, you don't have music. And if you have bass problems in a room and you don't have the proper underpinning, or if it's lumpy and tends to sustain too long in the room, you dramatically affect the musical enjoyment that you get out of that system. So we did it for two reasons. One, correction was required for me. Again, we're talking about me. And in the end, you hope that enough people in the industry agree to keep you in business. But for me, it was mandatory. And there's just no way by knowing the woofer and by knowing the enclosure and by having control of the amplifier that drives all those, you can optimize a closed system to outperform anything at 3, 4, 5, 6 times the price. In some ways, they'll never be able to challenge it at any price because of the adjustability that it offers. So that's, in a nutshell, why we've been doing it now for 40 years.
Okay, great answer. Let me take a look here. Um, I know someone was gonna ask this. Can you expand more on what you meant by analog has more information than digital? I'll preface this thought by saying that I am totally an analog guy and I agree with you, but that's my opinion. And but there are a lot of people who, they have really beautiful sounding digital streaming systems and put a lot of money into them. And for them,
And it can be very, very good. That's not, and I'm not taking away from that. However, there have been occasions too complicated to get involved here where where I have been able to compare a good digital copy of exactly the same master to a good record of that same master. And there was some sound effect encoded in the background. In one case, it was a cue sound. And it's very obvious that there is more information, more of that spatial stuff going on, where in the analog one than there was in the digital one. Anytime you convert energy, there are losses. That's an engineering fact. That's a law of nature. And as crude as the record as an LP is, it's still a very simple system. And it is devoid of a lot of timing errors that I believe we humans are more timing devices than amplitude devices. And I think therein lies the issue, the timing, all of the destruction of timing that can happen in the whole digital process. But again, that doesn't mean that digital can't sound very, I use that myself for convenience.
Okay. This question is, are there technologies on the horizon that you are exploring for future designs?
Yeah, but again, like in the past 50 years, they are more the application of materials, further developments of better sounding capacitors, passive components. It's you still using the same basic building blocks, but improvements in especially speaker diaphragms. It's very difficult to make a diaphragm where every square centimeter of that diaphragm acts in perfect unison to the voice coil that drove it. We call that pistonic. There are other pistonic drivers out there, but most of them are very stiff and very hard because that's what you need. And they don't have the balsa, which is in our patent, to dampen it. And they have very severe breakup modes when they do break up, which forces you to use steep filters to not hear that big peak when they go into their first breakup mode. And of course, if you have to go beyond first order filters, then it can't be time and phase correct. So I really don't. People say, Richard really loves first order filters. And I really don't like them that much, but it's the only thing that's time and phase correct. So I have to work with them. So yes, we're working on new stuff, but I haven't seen anything in the last 50 years that was truly, other than applications and improvements on what we've been using for 50 years, I think that'll continue. I haven't found a way to move air with no moving parts successfully. So nothing. I wish I could do that, but I've
Along the
heard
same, sure. Along the same line, someone asks if you've ever considered exploring electrostatic speaker design.
I made many electrostatic designs in the early principle, but there is so much time smear in them. Even if you look at the distance between your ear and the panel, and then go to the extremes of the panel, the change in distance alone, um, and it's very lightweight membrane, which is good, but it's also in a very weak force field. So for me, it was not it was kind of the antithesis of being perfect piston or totally pistonic. That membrane, and if you get the light shining on it right and play music, you can you can see it doing the jig in there. I mean, that membrane is all over the place. It's not moving like one perfect panel in perfect unison. So for me, they didn't do what I needed, and I understand there are a lot of good sounding ones out there. It just wasn't what I was looking for.
Fair enough.
So it was unfortunate because they're easy to build in house. I was hoping that that was going to be the solution. It didn't turn out that way.
Right. Would you say that's the same for planar speakers like Apogees or Maggies, the same, but maybe not quite as much? Or
And in that sense, yeah, if you're going for waveform preservation, preserving that waveform as it was made by the instrument that made it, they all have that same interpanel interference kind of thing where the distances, now, one might make one shaped like a parabolic to where all of it was exactly equidistant from from your ear. Uh, but I never tried that. That would be pretty complex, but that would be a way of getting those all of those arrival times right on the money. I I wouldn't know how you'd go about that, but that might have a possibility. I don't know. You'd have to be careful that the whole diaphragm itself wouldn't then cause the acoustic artifact of sounding like cupped hands. I don't know how you'd get around that, but I'm not saying it can't be done. I just haven't discovered it, nor have I heard it done.
and along the same line, some people want to know your thoughts on using concentric drivers in lieu of separate drivers.
Well, concentric drivers, very definitely, we use it in our center channels and we use it in our little bookshelf and we use it on our on wall for home theater because there you can't define where the listener is. So you can't align discrete drivers for that listening height. If it's a vertical array, all you have to concern yourself with is height. So all of our products where that's not possible to define the listener position, we use concentric drivers because even now that we have a moving diaphragm baffle, so to speak, around the tweeter, and it has its own share of diffraction effects and interaction and so forth. I consider it not as clean in time and its resolution as discrete drivers aligned properly. If you're in a situation where that's not possible or don't want to deal with tilting the speaker to get the listener at the point at which the designer designed the ears to be, absolutely, that's the only way to get there.
Okay. Your thoughts about horns?
I I think they have a very interesting and sometimes positive color. And again, it wasn't for me,
Hmm.
but it's interesting. I look at the over the 50 years. I did an interview not long ago. Uh, said, what was the impetus to do this, that, or the other thing? And I said, well, I've seen in my 50 years of convergence, wires don't sound as different as they used to. They've converged. Tube preamps don't sound soft and woolly anymore. They're quick and clean. Solid state isn't bright and nasty anymore. It's become actually some of them are very good. We have one coming out ourselves that's now in production. Uh, and wires, and cartridges don't sound nearly as different as they did many, many years ago. But when you get to that box in the, of speaker designs, it's like somebody threw a stick of dynamite in it. It's all over the map, so many different things. And I've often felt like, well, people are looking for the color that makes the music they love sound best. And there's nothing wrong with that because 50 years ago we took their tone controls and everything away. And so there was no way to make them pleasant to listen to. So that's a kind of a natural thing to happen. But it's also why we want to bring them back.
I mentioned earlier when we first started that your early designs and some of your current designs are, baffle free, and I assume that was again to reduce secondary radiation issues within the speaker. Is that something that you think can be solved without doing an open baffle design? I don't know if excuse me on this, your sevens, never gotten the opportunity to hear them. Are they still also an open baffle design, or are they enclosed?
There's two ways people describe open baffle. One of them is that the sound up, there's as much sound coming off the back of a cone in the mid-range as there is in the front. So open baffle usually in some circles means that that energy from the rear of the cone is allowed to go into the room as the front. We don't do that in any of our products. What we do with the open architecture that we use is to get rid of the diffractive effect of the baffle. This was described many, many years ago by a man named Olson, where the less baffle you have around the drivers, the energy kind of comes out of the cone looking like dropping a pebble in a pond. And that energy then hits the baffle and is reflected back to the listener, now somewhat manipulated in both amplitude and time. And so our narrow baffles from the ones, the twos, the threes, even our trios, quattros, quintos, and sevens, if you look very carefully at them, or if you took and looked at the old original two and take the dowels away and the top and bottom away, you'll see that what you have are very narrow baffles, just like the quattros. In fact, the trio actually has less baffle area made as a truncated pyramid leaned back for alignment. It actually has less baffle area than a Model 2 does. But anyway, it was just the eliminating the diffractive effects of the baffle itself.
Okay.
And that's still universal in all our products.
Can you talk a little bit about, because again, you have 50 years of experience, what you think the current state of high-end audio, or, higher quality, I don't know, quality is probably not the best term, but, are the industry in general, uh, is these days? Do you think it's still moving ahead? Do you think it's, years ago, everyone said high-end audio was dying? Of course, they said vinyl was dying too, and more vinyl being sold today than CDs for sure. Um, just in terms of your long perspective on the industry in general.
I think I've seen some recent changes. One has to remember that the definition of anything specialty is defined ultimately by few people care. In all walks of life, whether it's wine, cars, cameras, stereo equipment, whatever, for most people, they're pretty easily satisfied, and it's good enough. It's easily good enough. We audiophiles have made this important in our lives, where we want to push the envelope. We want it to be better than good enough. And within that circle, I see products and endeavors to get closer to the truth. You see a lot of products that are really driven more by what people like, where the music is the source or the stimulus, but there's deliberate things done in the design to not necessarily accurately reproduce that, but to reproduce it in a way that a segment of that high-end community likes it. And and then in recent years, I've seen more of an emphasis on the cachet part of it, the where you have a lot of money invested in the looks or the prestige of it that doesn't necessarily offer a performance advantage. But this is all good. I'm not into that part of it. I'm not that kind of a person myself. but there are people that are, and there's no reason why they shouldn't have that available to themselves. To me, I only reluctantly put a penny in cosmetics because I could care less. I'm more a form follows function guy. But I do have marketing people and dealers that say, tell me, hey, you got a deal, you got to at least uh, address some of these issues. And we have over the years. The trio is basically, I've had many, many hundreds of thousands, probably without exaggeration, of people saying, can't you make the Model 2 look better? Well, we did. It's called the Trio. It's the same speaker. It's just now it happens to be in an inert cabinet. It happens to be in a box within a box so that we can deal with the energy in the cabinet. But for all intents and purposes, it's a Model 2 that was made to look good. But I did find ways, after spending all that money, I did find ways to make it better because that's just my nature. That money had to go to being better, not just better looking.
Very good. Maybe you could speak a little bit about some of your electronics coming out of Vandersteen. I know you have your own, the the M7 HPA, and now I think you just recently introduced or released your, I don't know, purest preamp, the L5 ACC. And in terms of what led you to decide to initially design your own amplification? Did you just feel that you could design an amplifier that made it better with your speakers than anything else, for the most part, that was out there, and that led you down that track?
Well, most of our expensive speakers had powered subwoofers. So in the world, in the universal world, their amplifiers have to be designed to handle woofers, different speaker wires, different impedance curves. That takes a lot of output devices. It takes emitter resistors. It takes on and on and on the compromises that have to go into an amplifier to make it survive the real world. And I said, now, wait a minute. I know the speaker load and it's time and phase correct. I know NPNs and PNPs are not truly equals and opposite. And we have this high pass situation anyway. So the fact that this in channel version that we make on the M7 first and then later on the smaller M5, it's the same circuit. We can eliminate the emitter resistors. We can eliminate the interstage resistors. We can eliminate all the output chokes that some have to use. We can eliminate all of those capacitors on the output devices that basically dumb them down so they won't oscillate. I said, we can take all of that out because this is a known world for us. So, but all of those, so we're down to 5 parts in the signal path because that's all we need. And I believe that's audible. And they've done very well in the marketplace because of that. It's not worth anybody else doing that because it's basically designed for our situation. And I don't intend to really get into the electronic business. I don't like doing what someone else has done. I want to admit, do something. I'm an outside of the box kind of guy. So that's where the amplifiers came from. And now we have that same all in channel, fully complementary circuitry applied to a preamp, where I think it's even more effective than it was in the power amp. And we have a section in it called smoke and mirrors. And I've been wanting to bring that back for 40 years. And, it has matrix, which is informed by the BSG qual thing that circled the industry about a decade ago. And with a lot of popularity, it's called matrix. We have a circuit in there for recordings that are embellished by when you use that circuit. Um, it acts like a little bit of reverb and it opens up the space and so forth. We have a very sophisticated way of doing bass boost and cut. We have a very sophisticated way of doing treble, boost, and cut without being in the signal path, by the way, because we had to assure the marketplace that if this was not in the box, would the box sound better? The reason that all of these features, tone controls and everything many years ago went away is because when we took them out, the preamp got to be better sounding. So we had to find a way to implement these with and guarantee people, prove to people that if they were not there, it wouldn't be one iota better. Well, that wasn't easy to do. That took some time to figure out. And turns out on a lot of recordings, these things, you end up develop patterns that just work almost every time. So we actually have 3 presets on there where you find, hey, I like 3 dB of bass boost because this is an old recording. And a lot of old recordings, they didn't put the amount of bass that was on the master because it would cause the cartridge to skip out of the groove and the record would end up being a return to warehouse records. So they mixed the mono and the bass and they cut the bass back because they didn't want records coming back. Well, so you find +3 sounds good on old rock and roll, old records, and a little bit of mono mix because they exaggerated. We had three different amounts of crosstalk or mono blend in the mono circuit, and so you get a little of that. You get rid of a little of that ping pong that happened in early stereo records, and -2 dB treble cut made up for the fact that they were made to pop on FM radio. And anyway, you find out that that works on 80% of the old rock and roll you listen. So you just hold down preset 1 button, or in my case, preset 2 button for about 5 seconds until the screen says saved. And then when you're in that mood again, you don't have to go through all of that again. You just hit that button and it goes there. One in my case is simply bass boost, like the old loudness button we used to have on our stuff for when I listen at low levels late at night, and you need a little bit of a bass bump in order to balance out the fact that our ears are not as sensitive to the bass at lower levels. Anyway, if you get nervous and you're afraid you have one of those buttons pushed in there when you're playing one of your treasured records and your knees start knocking, the biggest button on the remote says direct. It takes it all out. You're right back to a straight, pure preamp again. So I think it's novel. I think people, you can order the box without it, $250 less. The preamp's $15,000, but you can order it without that module. The buttons on the remote won't work, but some of the buttons anyway. And for $250 less. But I think most people are going to enjoy it. We've taken it, Brad and I've taken it across the country, introduced it maybe to 200-300 people. Over 90% of them, their reaction is, how do we live without this? So we'll see. The marketplace will, as usual, the marketplace will tell.
Great.
So again, I didn't really want to make a preamp, but this is definitely going to be considered an out-of-the-box preamp. Line stage. It's actually an L5. That means line stage.
Here's a question. What do you do to keep your speakers capable of maintaining their sonic quality over the lifetime of the product, be it drivers, caps, resistors, et cetera, et cetera?
That's a good question. If you're not very careful with diaphragms, when I say diaphragm, that's a dome for a tweeter or a cone for a mid-range or a cone for a woofer. If you're not very, very careful selecting those materials and designing them correctly, one of the best sounding ways to make a cone is still paper. If you do an advanced material, carbon fiber like we use, and you don't do it successfully, it'll be less musical than accepting the losses but going with a good paper cone. One of the reasons why I can't say never, why I very seldom use paper is because those characteristics, humidity and all that, do play on that. Crossovers, you use film capacitors. Anytime you use an electrolytic because you need a value that's so big that that you're forced to, you always bypass it with a film cap so that the film cap deals with most of the ripple. And in my 50 years, we've never had an electrolytic fail. You hear a lot about how they go dry and they do this. I've seen no evidence of that, but then I've always bypassed them with a film cap to deal with the ripple part, and that is the part that is tough on capacitors. And yeah, good quality parts. They're dipped, hermetically sealed in a compound that we dip them in, a conformal coating, always have been. So I mean, we've got people out there with speakers of ours that are 50 years old and they're still enjoying them. So, there was no planned obsolescence in them, but that was by intent, by the materials we used and how we used them.
Great answer. Can you address the advantages or disadvantages of bi-wiring and the reason you use screw type connectors?
Okay, that's two questions.
Yeah.
By wiring, there is a good FAQ on our website that's a lengthy discussion of how it works, but I'll give you a short version. Anytime a woofer, and I'm talking about a woofer now that is large enough to have mass, enough, a significant amount of moving mass. A speaker, when it's hit with a signal from an amplifier, sends back to the amplifier something called back EMF. And it's pretty high in current. And it forms a magnetic wave around the wire that it travels through. That strong magnetic field, because of the base energy that's being driven, can modulate the real subtle information that's going to your tweeter. So if those wires are physically separated an inch or so or two, or randomly while they're going around the floor, you keep that magnetic field that's expanding and collapsing around the wire going to the woofer from messing with the delicate stuff that's going to your tweeter. It is very audible, very easy to prove. But if you do the experiment with one of these wires that's bi-wiring within one sheath, you've lost that most of that magnetic isolation process. And people report, well, it didn't make much difference for me. And I agree with that. It's not going to, because you haven't separated that magnetic field. It's easy to demonstrate. All you have to do on some of the early Vandersteens especially is get a couple of dual banana plugs, make shorting bars out of them. Get a couple of audiophiles, the most cynical one you can find, and put blinders on them so he can't see, and play him a system, and then have two of you, other people in the room, get behind the speakers and simply use those shorting blocks to connect the pluses and the minuses together behind the speaker randomly, in time with each other, and you'll see the sound stage collapse. I mean, it's a dramatic demonstration. Now we still have the doubled wire. We still have all of the exact same connections. All we've done is tied them together at the speaker and defeated the whole principle called bi-wiring. And it's a quick demonstration. We used to do that a lot at seminars. That battle I thought was over a long time ago. But the industry doesn't understand a lot of what it is, because I see speakers with little 5-inch, 6-inch woofers who don't have a lot of back EMF, and yet they're set up for bi-wiring. There's going to be very little benefit there because you don't have that much back EMF and current going to that small driver to create the problem. So our 1Cs, for instance, are not bi-wired. Neither are our little VLRs. So anyway, if you want to know more about that, it's easy to prove. It's not a joke. It's very serious stuff. And the crossovers need to be totally isolated. I've seen some bi-wired setups where all they did was they left the negatives common to both the upper and the lower section, and they only split up the crossover for the positives. In that situation, you know, anytime you pass current, what goes has to come back through the minus. So they have them common. That's not a legitimate example of what bi-wiring, as I do it, means. The terminals is a very good question. Many years ago, there was a bid put out. Disney was going to do an outdoor venue. I don't even remember what it was. And they were looking for people to design speakers for this outdoor venue. And one of the requirements in the specifications, this is like 45, maybe, yeah, 45 years ago. And we were looking for work at that time because we hadn't established ourselves yet. And one of the requirements in the specification is that they used terminals, screw terminals. So I called the engineer, the head of the project, and I said, you know, the common way to hook up speakers today are banana plugs, you know, in the form of a 5-way binding post, so you can't use bananas or whatever. What's this about the terminal strips? And he said, well, we can't afford to have somebody go through the whole system outdoors with hundreds of pairs of loudspeakers and clean those connections every year because it's an outdoor venue. And I said, we need a gas-tight connection. So I started experimenting with all of these exotic connectors and everything and listening on my straight wire bypass box that I test resistors, capacitors, connections, cables with. I've made it 50 years ago and I still use it. And I started listening to all these different connections and came up, you know, connections with a lot of metal in them sound dark. It softens the transients and they just sound dark. Connections that are made that are very good, but are easily corroded because there's air has access to them, can have like a diode effect and get a nonlinear sound to them. So the reason we use terminals is it's the best sounding connection I have ever heard, bar none, at any price. And you know what? A year from now, it'll be just as good as the day you made it, because using a ring lug and a binder, what's called a binder head screw, it is truly gas tight. So we slowly, after knowing that, started applying it to everything we make. Frustrates a lot of people, but it makes a noticeable different. Again, it gives a really good return sonically for the investment, and that's what has always been most important at Vandersteen Audio. Is that okay? We have products at all different price ranges, but I want people to feel like they got what they paid for.
That's great. Great answer.
So that, in a nutshell, is why we use barrier strips with
Yeah.
millions of complaints.
I can imagine people buy, as you know, very expensive, very large, heavy speaker cabling with monstrous lugs and, I mean, you know, spades on the end, whatever, and it won't fit or whatever. Yeah.
You know, maybe if it's a big 24-inch woofer with a 6-inch voice coil on it, and it has about a half an ohm impedance, maybe that would make a difference in the bass because it's a little lower in impedance. But we don't do that in our speaker enclosures, so it is what it is.
Anyone else have any other questions? We're at about an hour. I've kind of run through mine. I might ask Richard to tell us a bit, something about yourself we don't know that has nothing to do with the audio world that you're willing to share, or that someone might find interesting. You mentioned earlier that you're into fish, the aquarium behind you. In your younger days, were you ever a diver or anything like that, or you've just always had a hankering for aquarium?
Yeah, dove until my dive partner couldn't dive anymore. And if you do dives as deep as we were going, it's important to have a good dive partner. And I haven't convinced any of my grandsons or my son-in-laws or grandsons to do it. So I haven't been on a dive in probably 10 years, but yeah, I used to be an avid diver. I
Mhm.
owned and raced a super modified for 25 years, track champion in 1996. That's when I should have retired because it was downhill from there, but that was just it. And yeah, there's so many things. I'm kind of an adrenaline junkie, so I built and my own airplane and flew to all the seminars that we've done all across the country with Enoch and my wife for many, many years. I'm not flying anymore. In fact, I'm in the process of selling the plane I built. Um, was into fast boats, raced boats.
Uh,
Now we're into motorhoming and traveling.
what kind of airplane? What kind of engine?
The airplane I built is a four-place Velocity. It's a Canard. The engine's in the rear. And I used an IO 550N Continental motor, and then I turbocharged and intercooled it myself. Um, that's a way bigger motor than that plane was designed for, but there's a function called lean at peak, which saves you a lot of gas, and but it does reduce your power. So I made sure that I had an engine big enough running lean at peak that was at the maximum power rating of the aircraft. So that's how that ended up. But it's a Canard retractable gear, four-place, lots of room. I air conditioned it, put weather radar in it and everything. It's a very comfortable way to travel. Full three-axis autopilot. Um,
I assume it has a good sound system. Oh,
no, I don't do sound systems in my cars because I never have them on. It interferes with my thoughts. And the airplane is so noisy in there with even with the engine in the back at 270 miles an hour, there's quite a bit of noise. I wear ear protection,
sure.
always wear ear protection for all this stuff. But
Right.
because of that, I can still hear pretty well.
We talked about this a little bit before everyone else got on, but one of our members wants to know your thoughts and experience about field coil drivers. Maybe you could reiterate a little bit of what we talked about and your thoughts on that.
Well, field coal drivers is the way it started, and I don't see any design advantage to them except in woofers, because with a woofer you could change the current going through the coil and change the driver parameters if you wanted to do different things. Now, so that's an area. There's no other way to affect the Gauss that you're generating in the gap that the voice coil is traveling in. So I could imagine that could be an advantage if you were doing some sort of adjustable base, not like the way we do it. But like I said earlier, we may all be going back to act, coils if they don't solve this rare earth problem with China, because we may all have to be using field coils again because we can't get magnets. But that's not been a problem so far, and it's kind of a half joke, but anyway.
Yeah, but that's a point. So
But it does give you some adjustability in a woofer enclosure, because a woofer enclosure is a pretty sophisticated mathematical model. And if you're able to adjust that view, you can change the Q of the driver. There's quite a few parameters that you could change. However, some people think that with a field coil, you could generate more Gauss in the gap. And that's not really true. Car audio is kind of an interesting thing. You see these 10 or 12-inch woofers with these 3, 4 magnets glued on top, these huge amounts of magnet on there. Folks, that's just advertising copy, okay? What focuses that magnetic energy in the gap of a woofer are the steel parts, the top plate and the pull piece that form the gap that that voice coil rides in. Once you've saturated that steel, the amount of flux in the gap actually goes down. So when you see one of these drivers that has just an unbelievable amount of magnets on it, if you were to take a Gauss meter and measure the amount of flux in the gap, it's probably would be less than if you took all of those magnets off and used only one. The actual field, the flux in the gap would go up. But you know, they're selling to a market where magnets are good, and they're not that expensive, ceramic ones anyway. So once you have to have those steel parts to focus that magnetic energy in the gap, and you know, different kinds of steel allow you to do it different ways, but there's a limit, no matter how much current you push through the coil, because like I said, once those steel parts uh, saturate, the Gauss will go down. The magnetic energy in the gap actually starts reducing.
staying on woofers, can you talk a little bit about, you talk about adjusting Q, and I know a lot of your speakers, especially the fives and those, allow you to play with Q and adjust that. Can you because I don't know if I really have a good understanding what maybe there's an industrial definition of what Q stands for, and then how do you go about from a circuitry standpoint of turning a dial, and what is it actually doing when you're changing the Q?
Well, you're mathematically simulating a different Q in the woofer. So maximally flat is considered to be a Q of 0.707. Maximum transient response is considered to be a Q of 0.5. British products, because their walls are heavier than ours, rooms are smaller, they tend to be cued at 1. And it's a matter of taste. So you can mathematically, it involves Q and phase, you can mathematically simulate this. And on our subwoofers and all of our other products, you have the ability to change the Q between approximately 0.4 all the way up to about 1.1. And that argument still goes today as to what a woofer should be cued at. And I figured, if you can do it, we've got the amplifier on board, we have the technology, let the customer choose.
And how does the circuit, maybe you answered this and I just went over my head, so I apologize ahead. As you're adjusting, how is the circuit actually changing the Q? Is it done
By changing the EQ, the frequency response, and the phase that mimics what happens if you do it in the box. In a woofer, it's oversimplified, but when you're designing a woofer, you can affect the Q of the speaker by making the box bigger or smaller, or the magnet bigger or smaller. And This is all done in modeling, so that you know what size to make the box or what frequency to tune the port to or whatever. But this is a way of doing the same thing, but doing it electronically, where you don't have to redesign the woofer box or the woofer driver.
Right. And is it doing it via different resistors within the
It's a
crossover?
pot.
Oh,
It's a
okay.
pot. It's a potentiometer in a circuit, and it
Okay.
involves phase shift and EQ, equalization.
What I'm wondering is how rigid and stiff and damped those baffles need to be to stay so narrow and support the speakers well. As is the damping of those baffles a critical component in the designs?
Yeah, the baffle is not really any more important than the rest. Well, it is slightly more important because the drivers are mounted to it, but in actuality, the entire enclosure is equally important because it can act like a diaphragm too. You don't want the whole box singing out of tune after the fact. The box needs to be inert so that the drivers can do their work cleanly. So there's a tremendous amount of energy in a box, and there's really not a damping material available that will truly damp the kind of energy that you have in a speaker. This and have enough room for that speaker left in the box for the speaker to work. So in actuality, what you have to do is you have to make the box. What we do anyway is we have a box within a box, and then you brace the heck out of it. So what you're trying to do is you're going to have a resonant frequency, and you have to move that high enough in frequency for these viscoelastic membranes that are between the inside box and the outside box, to be able to turn that higher frequency into heat. Because if you left it where it wants to be, 400, 500, 600 hertz, there's really no material that's going to dampen that effectively. When you talk about you got two sides, a front and a back, all of them needing to be inert. You're going to have to fill that box with I don't know, bituminous tiles of some kind, but then the woofer wouldn't have enough room to work. So the way we do it is this box in a box, brace the heck out of it so those resonant frequencies are high, and then deal with it with this Vasco, which is just sticky stuff that never cures in between the two layers. Good question.
Yeah. Question in regards to kind of footers that you add to your cabinet designs and how that may affect, the resonance of the cabinet.
Footer's a big deal these days. A lot of people doing it, and I understand why. Most speakers are made excessively bright in order to make it easier to sell them. And putting a footer under there that absorbs some of the energy, some of the work that's put into the room, will soften the sound and maybe more pleasant. Our designs, and I got to say this very carefully, this is only true in my model, which is a concrete floor poured on terra firma, poured on the earth. All of our designs, all of our measurements, all of our that we use with accelerometers and distortion figures that we take, what we want that speaker to be held as rigidly in space. We don't want it moving, because small amounts of movement in the enclosure can cancel a lot of the work done by the tweeter. So we want that speaker to be like an anvil that a blacksmith uses to make horseshoes. We don't want to put the poor guy out there in the grass and say, make horseshoes. We want those drivers as rigidly held in space as possible. Now, once you get onto a tympanic membrane, like a floor over a garage, which are the worst because you have a large span and that floor is going to really want to bounce in the middle. All bets are off there because now you've got your speaker setting on something that's already moving. So all of our speakers are designed to be used with spikes, decoupled at high frequencies, only, for resonance purposes, right down to the concrete floor on 3 spikes. That guarantees that they are all 3 equally loaded because 3 points defines a plane. Now you can put all these different feet under there and change the sound of the speaker, but most of them have compliance. Most of them are going to allow the speaker to move, and that will reduce the dynamic contrast or the output that the tweeter or the mid-range especially, because you're dealing, a tweeter reproducing a lot of what it does. We're dealing with, tens of thousands of inch of movements, very small movements, pushing on the air in that room, creating that wave that impacts our eardrum. Any counter, the woofer going positive that's allowed to move that box backwards, any amount's going to cancel some of that, be anti-phase, and cancel some of that energy that the speaker is doing. On tympanic membranes, you just got to do what works, because there you don't have a solid, do anything you can to shore up that floor so it doesn't move. Because then your other option is to put some kind of a decoupling spring under there, and a spring on a spring can be a nightmare. You can get reduction in distortion, but you can also get amplification if they aren't tuned correctly. So everything I say about footers applies to my world, which has been exclusively concrete floors on the earth.
Well, this gentleman asks your thoughts on designing a speaker box that incorporates a reflex bass design, but I think you covered that because you get around by, again, using kind of a baffle-free design, right? Am I correct in that?
Most people, when they ask about reflex, what they mean is ported. Passive radiators and ports, slot loading are all terms for the same exact mathematical situation. So we use a variation of that in the Model 1, but for the most part, everything we make is sealed enclosure, because ported enclosures always give you a secondary bump. In other words, you have a lot of overhang, and there's really no way to deal with that. So if you're into this whole time and phase thing, a woofer in a 24 in a ported box, like a B4 alignment or whatever, has a roll off of 24 dB per octave, but you put one bump in, you get 2 out. So it's not as defined as a sealed enclosure would be. So almost everything we make, with the exception of the Model 1, is a sealed enclosure in order to get optimum transient response.
Okay. The gentleman asks, can you tell me what is quarter wavelength transmission line loaded?
All of our mid-range drivers, our early patent, which is now long gone, but was about the aerodynamic magnet structure on the mid-range. You have as much sound that comes off of the rear of a cone on a mid-range, for instance, as the front. This rear energy on typical drivers bounces off of this big round magnet, which is about as big around as the cone in many cases, and the basket and everything, and is reflected back through the listener, now messed up in time and amplitude. So our patent was this aerodynamic basket with a very small magnet to reduce this we call it internal diffraction issues that go on within, especially mid-range drivers. Now, what do you do with that energy? Okay, we've let that energy come from the back of the cone. We're not splashing it back at the listener, but it needs to be attenuated. So you design the enclosure behind the mid-range, and usually you need to 45 it up or down in order to get a quarter wavelength. But the idea there is to have enough distance behind the driver for that energy to be dramatically dissipated before any part of it will want to come back through the cone and mess with the listener again. I think maybe that's what he's asking about.
Okay. In regards to mid-range drivers, can you speak a little bit? You're talking about classic cone style drivers.
Right.
What about dome mid-ranges? Do they offer anything advantageous or disadvantageous in your mind?
The difference between a dome or a cone, no matter how you shape it, assuming they behave the same mechanically as far as breakup modes are concerned, really doesn't change anything. It's just a way of moving air. However, for tweeters, most of them are shaped like a dome because that's inherently stiffer and you get better. Even a soft dome tweeter is pistonic up to about 8-9K before it hits it turns into chaos and starts its breakup modes. So that's pretty high. That's above most fundamentals in music. Our Perfect-Piston thing is most paper cone mid-ranges, for instance, have their first breakup mode by about 900 hertz. There's a video on our website that shows a good 4.5-inch paper cone, Egyptian paper cone, and its breakup behavior compared to our carbon balsa one. And you'll see that you got over half of the area on that cone out of phase with the voice coil. Now, it's because of that, as you approach high frequencies and you're trying to cross over to a tweeter, that tweeter is pistonic. That means its dome is moving in exact unison with the voice coil. Okay, voice coil goes out, dome goes out. Every bit of that dome goes out, okay? On the mid-range at that frequency, now we're in the breakup mode and the edges of that cone are 180 degrees out of phase with the voice coil. Well, if you wire those in phase, you're going to get a 12 dB hole in the response because the mid-range has more area than the little dome does. And at those frequencies you're trying to cross over, it's now out of phase with the voice coil. That's why you have to reverse the phase of the voice coil. So in that transition region, that part of the cone that's reproducing those frequencies is now in phase with the tweeter dome at the lower frequencies. It's a little complicated, but you can see that. It's evidence of the fact that these cones, once they go into breakup modes, are in total chaos. You can see that on waterfall plots is the easiest way to see it.
Mm-hmm.
Some speakers, some planars, the waterfall plot looks like a really bad storm in the ocean. Remember now that all of that energy in that stormy looking front part of that waterfall plot is all energy that speaker put into the room on its way to your ears after the amplifier signal stopped. There is no input to the speaker anymore. So you can call that speaker character or whatever, but something in that speaker created all of that out of nothing because the stimulus is gone. It's like a bell. You strike a bell with a mallet, it keeps ringing, but the mallet is not hitting it anymore.
Right.
That's another analogy. But a bell is the epitome of breakup modes. You're doing it on purpose because you want it to take off. If it didn't, it wouldn't be a bell.
Sam asks, and this maybe, I don't know if this is too big a question, but how phase and time alignment is accomplished at Vandersteen with your speakers?
Well, there's only one way, absolutely only one way to do time and phase alignment without DSP. So we're talking about analog in the loudspeaker.
Right. Right.
You have to use first order filters. You have to physically align them so all the voice coils cause the drivers to speak at the same moment. It cannot be corrected for in the crossover. So you have physical alignment and you have first order filters, and you will create that impulse like you'll see on our measurements on our website, or you can look at John Atkinson's measurements. But you can tell it's time and phase correct by having that. It's shaped like a leaning a triangle leaning forward. The first part of that is created by the tweeter. The next part of it is created by the mid-range, and the tailing end of it is created by the woofer, all of them summing, the input being a square wave. Well, because it's not DC to light, the leading edge is leaning a little bit, and because the woofer doesn't go down to 0 hertz, it's kind of tapering down to the baseline. Remember, the stimulus was a square wave. So that's the only way to tell whether a speaker is truly time and phase aligned. All of those drivers will align to give you that leaning triangle.
Excellent answer. Thank you.
A lot of other people, line drivers, stagger drivers, claim that they're time aligned, but if you look at the impulse, they're not. They're adjusting for something, I'm sure, but it's not to be time and phase aligned.
And if you were listening to speakers with the same drivers, and one was, I mean, if you could turn off the time alignment, I don't know if this is a fair question, but what I'm trying to get at, if you have two speakers and one is time aligned and the other one isn't, and it's the same recording, from the listener perspective, what do you think is the biggest thing that you notice when you have a really truly time aligned, pressure wave, coming from the speakers, same recording, sound staged, separate everything, I don't know. I'll shut up and let you answer that. So
yeah, I've done that. And the quick answer is not much. On first listen, first of all, when we first listen to something, we listen to amplitude, which is tone. That's pure frequency response. Well, depending on how well you did the experiment, if the non-aligned version was flat and the aligned version was flat in frequency response, that part of the sound is exactly the same. Because to make a difference, you'd have to screw one of them up. Okay? So, like I say, the quick answer is you don't hear much difference. As you play music on the system that is aligned, you will be frequently reminded that could have happened here. The experience, and you're going to be less aware of the fact that you're listening to speakers. The whole idea of it is to make those damn speakers go away and let the music play. Okay, take the emphasis off of the speaker or the fact that you're listening to hi-fi. So I think this is where a lot of people get in trouble. They hear a lot of good sounding speakers, and they are, that are not aligned. And they say that Richard Vandersteen's full of shit. It doesn't make any difference. And I understand that because it doesn't make a big difference. However, once you get used to it, everything out there, no matter how good it sounds, is just a little bit wrong. It's just not quite like it could have really happened. I don't know of any better way to explain it. But the big part of the question is, sometimes I can get so adamant about the importance of time and phase alignment that one could imply that I'm trying to say everything else is going to sound broken. That's not true. I wish it were true, but it's not true. It is a subtle thing. However, once you latch onto it, it's not so subtle anymore, because it's a big part of being able to get into the music more than the hi-fi. Now, there are a lot of people that are in this business because they love the gear. Music is just a secondary thing, and I understand that, but that's what was important to me.
Mhm. I'm going to finish this up. We've been over, a little over an hour and a half, but I got at least one last question here or so. Do your speakers need break-in time at home after receiving them?
Yes, they do. Break-in is a real phenomenon. Even film capacitors form, their dielectrics form, and the capacitors become more linear. The suspensions and the surrounds of the woofers and the mid-ranges, and even the tweeters in a little way, do. Most of these, we use lossy surrounds to terminate the cones so that you don't have reflections coming from the surround back into the cone. Those surrounds are made by injecting either carbon or some kind of a particle in the rubber that they're made out of. And it takes a fair amount of playing them for that. That all ends up being an injected process where it's turned into a liquid and injected into a mold. It takes a while of playing for those particles to release themselves from the bond of the rubber so that they can truly act like a resistor and terminate the energy. So they start off being reflective and they finish being absorptive. So that's a noticeable change. None of this is day and night, but it's legitimate. I don't do any design work unless the driver's had about 1,000 hours on them.
I think we'll finish with this last one. As a percentage of the existing volume, how much bracing or dampening can you change or add? Sounds like someone who builds speakers asked that question.
Say that again now.
Sure. As a percentage of the existing volume, how much bracing or dampening can you change or add?
Well, you can put any amount of bracing in an enclosure that you want, but you do need to calculate that most of these systems are resonant tune systems, whether they're ported or sealed box. So the volume of the air in the box needs to stay the same. So if you put a lot of bracing in it, the box needs to be a little bigger to make up for the space that the bracing has occupied. I think maybe that's what he's asking.
Yeah,
If it isn't, maybe clarify his question.
sure. That was, let's see, 1 second here. That was from Bill Graves. Bill, did that answer your question? If not, do you want to unmute yourself and ask it again or some other way?
Well, yeah, I'm thinking of not building one from scratch, but taking a vintage speaker of whoever's brand and trying to reinforce and dampen the bass enclosure part of it. And how much leeway do we have in trying to brace it and that kind of thing?
Well, I'd be careful there because it depends on how well designed it was. But assuming that the port was tuned correctly and the parameters of the driver and all of that was done correctly, then any bracing you put in there is going to occupy space. and that
Right.
would not be a good thing. You might, if there's a way to put the braces on the outside of the enclosure, then you could stiffen it up without affecting the internal volume. But that's one thing you need to be careful about.
Thank you. Thank you, Bill. All right, well, we're at a little over an hour and a half. I'm going to finish this out and thank Richard Vandersteen. Thank you very much for your time and answering a whole assortment of questions. It was great.
It's my pleasure, and these things are always interesting, especially when the questions are good, and they were. So, my pleasure.